Okay, so last but not least is lesson 23's classwork. So in lesson 23, we're learning about ratios. We're sort of done with division, and now we're working with this idea of a multiplicative comparison between two amounts, which is what a ratio is. A ratio is a multiplicative comparison between two amounts, and the multiplicative comparison is expressed as for every. So for example, for every 5 boys in Mr. Holland's music class, there are 15 girls. So it's asking us, what is the multiplicative relationship between boys and girls? And at any point in this video, you should probably stop to see if you have the same answer that I do. So we could express this two ways. We could say that they are 3 times, because we're making a multiplicative comparison, there are 3 times as many girls as boys in Mr. Holland's class. However, we could also say that there are 1/3 as many boys as girls in Mr. Holland's class. Cool. So this division line is read for every. If you write it using words, it's saying 5 boys for every 15 girls. And you can write it using a colon. The colon is also for every. So 5 boys for every 15 girls. And now there are 2 different kinds of ratios, right? You have part to part, and then you also have part to whole. So let's take a look at some of them. Continuing with Mr. Holland's music class, consider the following statements below. For each one, indicate by circling the correct answer if the comparison is part to part or part to whole. So in the first one, we have 15 girls to 5 boys. I should probably read that for every. 15 girls for every 5 boys. So, right, the number of boys in the class represents part of the class, and the number of girls represents part of the class. So this is a part-to-part comparison. 5 boys for every 20 children. So if we're talking about children, obviously we're talking about the whole, right? There's 20 children altogether. So this is a part, the part of the class that's boys, and the whole is 20 children. 1/4 of the children are boys. So we're still talking about part of the class, right? The part of the class that are boys, and we're making a comparison to the entire class, all of the children. And last but not least, we're back to part comparisons. We're comparing girls and boys. Three girls for every boy. Cool. Page 205. So moving on to equivalent ratios. In an equivalent ratio, the multiplicative relationship between the two amounts is the same. For example, if there were exactly 10 boys in Mr. Holland's classroom, then how many girls must be in the class to keep the same ratio? So in other words, if we doubled the number of boys, because we had 5 boys in originally, and now we're doubling that to 10, if we want to keep the ratio the same, we're also doubling the number of girls. You can also look at it this way, right? If the ratio of boys to girls is 1 to 3, or 1/3, then if I have 10 boys, then to keep the ratio equivalent to 1/3, there has to be 30 girls. Right? As you can see, there's a 3 times as big relationship between boys and girls in both ratios, so the ratios are equivalent. The equation above is called a proportion, and a proportion is basically just saying that 2 ratios are equal to each other. So proportional reasoning problems involve equivalent ratios where you typically have 3 of the 4 quantities given and the 4th is unknown, just kind of like how we had here, right? We had the original ratio, we had half of the equivalent ratio, and we had to figure out the 4th part, right? Children in middle school or even younger than that are often asked to find the unknown quantity. So for each ratio provided below, generate 4 equivalent ratios and try to have at least one of the ratios be the simplified version of the original ratio. So if we have 15 girls for every 5 boys then, and we want the simplified ratio, that's 3 over 1. Right? So we're making ratios that are equivalent to 3 to 1 or like a times 3 relationship. So we could say 12 girls for every 4 boys. I'm going to put G and B there. We could say 30 girls for every 10 boys, kind of like how we had up here. We can also say 18 girls for every 6 boys. These all represent, right, the same ratio where for every 3 girls, there's 1 boy. Take a look at the second one, 15 girls to 20 children. So this, if we were to simplify that, we would get 3/4. So 3 girls for every 4 children. So we could do 21 girls for 28 children. That's 3/4. We could also do 18 girls for every 24 children. That's 3/4. We could also do 9 girls for every 12 children, and that's also 3/4. Last page. You probably learned the cross multiplication algorithm to solve proportional reasoning problems. However, this algorithm does not help children create meaning for equivalent ratios in proportional reasoning problems. So by cross multiplication, what they mean is like this. And usually, you multiply those two numbers, right? You cross multiply and you get 160, and then you divide your answer by 5. I believe that's 32. Okay, but children often struggle. They don't know why they're doing that. They don't know why this works. So when we are working with children and we're introducing the topic of ratios, to really hammer that for every point in, it's good to use pictures or a table or some sort of diagram. So that's what we'll do. Imagine we're 5th graders. How can we represent and solve each of the following problems with a picture? So at the pet store, there are 3 rabbits for every 4 mice. If there are a total of 15 rabbits, how many mice are in the store? So I can represent this, right? For every 3 rabbits, there are, 3 rabbits for every 4 mice. It's saying there's a total of 15 rabbits. But our ratio looks something like this, right? So if there's 15 rabbits, 9, I'm not drawing because I'm a terrible drawer, 3, 6, 9, 12, 15. And we know that, right, there's 4 mice for every 3 rabbits. So, and the question is asking us how many mice are in the store. So 8, 12, 16. There are 4, 8, 12, 16, 20 mice in the store. And I could also represent this using a table. So I could do I can also use a table to help me out. So there's 3 rabbits for every 4 mice, which means 6 rabbits for every 8 mice, 9 rabbits for every 12 mice, 12 rabbits for every 16 mice, and 15 rabbits for every 20 mice. Cool. A 5-minute shower requires about 17 gallons of water. How much water will you use for an 8-minute shower? Interesting problem. So We can also use a double number line to help us solve ratio problems. So if I know that 5-minute shower, this number line will represent minutes. And this will represent gallons. We could say 715 gallons a minute. Excuse me, 7/15 gallons. Actually, no, that's right, 7/15 gallons a minute. But to make it a little easier to understand, what I will do is I will extend my number line. So if I know that it requires 17 gallons of water for every 5 minutes, I can make it a little bit easier to understand what I'm talking about if I extend my number line to 10 minutes. So if I know that in 5 minutes I'll need 17 gallons of water, right? Kind of what we did when we were working with percents. I know that for 10 minutes I'll have to double this, right? It's just like what we did here, right? With the boys and the girls. So if I double the number of minutes, I'll double the number of gallons as well. And 17 times 2 is 34. Knowing what we know about 10, right? We know that 1 minute, if I'm using decimals, that would be 3.4 gallons. If I'm writing that as a fraction, that's 3 4/10 of a gallon, or 3 2/5. And now they're asking us for 8. But because I know how much water I'll need for 1 minute, it makes this pretty simple. Right? All I have to do is keep adding 3.4 until I get my answer. So I could do 3.4 times that by 8. But I'll just keep going. That's 6.8 gallons. What's that? 10.2. Add another 3.4. That's going to be 13.6. And if I know the amount for 4 gallons, I could just times that by 2, right? That's 27.2. If I were to write that as a mixed fraction, that'd be 27 2/10, or 27 1/5 gallons. Okay, so many ways to look at it. Earlier I said 17/5 gallons a minute. So if I did 17/5 gallons, I would have gotten 3 2/5 gallons, which is the same as 3.4. So I could have also done that to tell me how many gallons per minute the shower required. If you have any questions, just send me an email.